We're going to learn how to simplify basic radical expressions. Okay, we have expressions with square root signs over them, or it could be any kind of root, cube root, fourth root, fifth root, any nth root. All right, so we'll do several examples, okay? Remember what this is really asking for you to do. It's asking you to take the square root of 4 times the square root of x cubed times the square root of y to the 5th power. That's what it's asking you to do. So you got to treat each term separately, even though it's like one term under the radical. We're going to treat everything separately so we can break it down, okay? So this is what it's asking you to do. It's asking you to take the square root of those, okay? And what you got to remember is that if you see perfect squares, in this case, 4, the perfect square of 4. So square root of 4 is 2. And then, of course, this is equivalent to square root of x squared times the square root of x. So anytime you have a odd power, we want to reduce it by 1, and that'll bring us to the nearest perfect square. Okay? So, and this one here is the same thing. Okay? That is equivalent to y to the 4th. We brought it down 1 power, and then the extra 1 just goes in its own radical. Okay? So now we have 2 more perfect squares. We have this one and this one. And now we're going to simplify that. So 2 square root of x squared is x. This just stays in the radical because we can't take the square root of x. Square root of y to the 4th is y squared because it's a perfect square. And then, of course, we can't do anything with that. So anything that's not under the radical gets multiplied together. So this times this times that. And that's going to equal 2xy squared. And then we multiply the radicals together. Okay, and that's going to be, you can write it as one radical. So that's going to be square root of x times the square root of y. And this is your answer. Okay, so let's do another one. So I have 81. Okay, what is that? So we have L squared m cubed n to the 7th power. Alright? And what is that asking you to do? Well, it's asking you to take the square root of 81 times the square root of L squared times the square root of m to the 3rd power times the square root of n to the 7th power. That's what it's asking you to do. We're going to look for the perfect squares. Well, the square root of 81 is definitely 9. And the square root of L squared is just L. Those are 2 perfect squares. Now this one is an odd exponent, so we're going to reduce it by 1. So that would be like m squared times m. Okay, so that gives you that. And then this gives you, again, it's an odd exponent, so we're going to reduce it by n to the 6th times n. Alright, and now we look for perfect squares. Again, this is going to be a perfect square, and so is this. Okay, so you have 9 times L times the square root of m squared is just m. That stays under the radical. The square root of n to the 6th power is n to the 3rd, because when you do n to the 3rd times n to the 3rd, and you add the 2 3's, you get 6. And then of course we keep that the same. So we're going to multiply everything that's not under the radical. That's going to be this times this times that. And that's going to give you 9 LMN. And then we're going to multiply the two radicals together. And that's going to give me the square root of MN. Okay? That's going to be your solution. Whoops, I forgot the n third. Because this was n third, so I forgot to write that. So it's 9LMN cubed times the square root of mn. Okay? And that's going to give you the solution for that. Alright, let's do another one. We can do cube root of negative 8 a to the 6th power, b to the 10th, c to the 14th. Okay, and what is this? This is basically asking you to take the cube root of negative 8 times the cube root of a to the 6th times the cube root of b to the 10th power times the cube root of c to the 14th power. Okay. Cube root of negative 8, that's going to be a perfect cube, so that's going to give me negative 2. A to the 6th power is also a perfect cube because a squared times a squared times a squared is a cubed, so it's going to be a squared. This one is going to be, we need to break this down so that one of them is a perfect cube. So I immediately think of the number 8. Okay. I'm sorry, why did I write 8? I meant to write b to the 8th power. So let me erase that. Actually, no, that's going to be b to b to the 6 is a perfect cube. B to the 4th. Okay. So we want to break it down so one of them's a perfect cube. So the one I can think of is b to the 6th power. Okay. And the same goes for this one. We want to be able to break it down into two perfect cubes. All right. So we can think of several of them here. I'm trying to think of the easiest one to pick. 9. We can say c to the 9th. And then that would be c to the 5th power. Right? So we have two perfect cubes. We have one here and one here. So let's do that and see what you get. Okay, everything else stays the same. The cube root of b to the 6th power is b to the 2nd power. This we can't take the cube root of. Okay. Actually, we could. We can break that down. And this one's going to be, I don't know why I wrote that down. Cube root of that, so that would be c to the 3rd power. Whoops. Okay. Okay, so this one can be broken down into one more perfect cube. So we can say the cube root of b to the third power times the cube root of b. And then this one we can say the cube root of c to the third power times the cube root of c to the second power. So we have two more perfect cubes here and here. All right, and everything else is going to be staying the same. Okay, so I'm not running out of room. All right, so again, if we take the cube root of this is going to be just b, right, for that one, and this one's just going to be c. Okay, so now we're going to multiply everything that is not in the radical, and that's going to be this times this times this times this times this times this. Okay, and I'll write it in green so we can see it. All right, so negative 2 a squared, and then b squared times b is b cubed, and then c cubed times c is c to the fourth power. Okay, and in red, I'm going to do everything that's that we didn't do yet. That's going to be this times this. Okay, and basically you're going to get the cube root of b c to the second power. Okay, so these two here, we couldn't do anything with that. All right, so we kept those under the radical. Okay, so my final answer is this. That one took some work because I broke it down step by step. All right, so that was a really good example. Okay, all right, so you get the general idea of, depending on what root you're doing, all right, you have to be able to find that perfect root, okay, when you split down the radical into separate radicals, okay? So in this case, we're doing the cube root, so we're looking for perfect cubes every single time, and we got to keep breaking it down, all right? Okay, so I hope that this video was helpful in identifying the very basics of simplifying radical expressions, okay?